Hello, everyone. Good morning. It is now 11:35 Central European Time, and we will start with this second session of a five-part series on digital transformation. So before we begin, I just want to emphasize that you should keep your audio muted and also stop your videos to optimize visual and audio quality for everyone. Keep your questions coming in during this session. I'll pick the essential ones, the most relevant ones, and pose them to Michael at the end. And of course, he has the liberty to answer questions on the go as he wishes. And before we begin, of course, let me introduce him very quickly again. Michael Gremlich is an instructor and freelance consultant for data science, machine learning, and data strategy. Before that, he worked as a data scientist at Alexander Thumb, consulting for multinational corporations across Europe. He is passionate about implementing data science and machine learning projects end-to-end, from their conception until the deployment of operational data products that generate real value. Michael is sharing his expertise and experience with data, which he has done in many trainings for various international companies and universities. He holds a master's degree in international economics from the Graduate Institute of Geneva. So thank you for being here with us, Michael, for a second time, and for the next 3 times as well. I'm sure this will be a very insightful webinar as the previous one was, and look forward to learning from you as well. Welcome again.
Hi. Okay, perfect. I had to look for the unmute button. Thank you very much, Edison, for the introduction again. I think you've said it all. So I'll keep my personal introduction very short. But before I do that, let me welcome everyone. I'm very glad that you're here. I am assuming that most of you were already here last week already. And if you are, then welcome back. If you're new, that's no worries. You should be able to follow this webinar without the webinar of last week as well. So who am I and why am I here? I think Edison has said most of the things. I'm a freelance data scientist and instructor. I've also written a book or co-authored a book about these topics, so about machine learning, AI, data analytics, big data. And you're more than welcome to check this out. Just visit my website or my LinkedIn profile, and also feel free to connect with me there in case you have any questions afterwards. So I'll leave it to that for my personal introduction. And I want to get right into it. So as Edison has mentioned, this is a 5-part webinar series. So we have quite a bit of time together, which is good because we're also going to cover a lot of topics. And just to recap what we did last week we talked about digital transformation. And you might remember that digital transformation was driven a lot by simply the digitization and digitalization of processes. So us being able to now send emails rather than postcards. And this has previously driven digital transformation. And this is a lot of innovations that companies have adopted so far. But we have also seen that increasingly, digital transformation is driven by data and by everything that you can do with data. And so recall that last week we looked at what big data is, what types of data there are, and where it comes from, how it's created. And the third thing we looked at last week was, or for me, the main takeaway for you guys, hopefully, was what it means to become data-driven as a company, which in a nutshell means basing all of your decisions that you take as a company on data rather than opinions or rather than a gut feeling, so that you make the best informed decisions. Good. So this is what we looked at last week. And what we're going to do today is basically we're going to have today and next week have a look at all the things you can do with data. And so basically, this is the entire topic of data analytics. And so the outline of today is that first I want to talk about data analytics. So we're going to see what it is. We're going to see also maybe what it's not. We are going to see some examples. So I've included the feedback from last week, and I've tried to cater these examples to the 4 relevant sectors we have here. So tourism, IT, textile and apparel, and what's the last one? Agriculture, agribusiness. So we'll see a lot of data analytics examples. And the reason why I kept my introduction short is because basically what I did, or what I do as a data scientist, is implementing such data analytics projects. And we're also going to have a look at the job roles there are, so that if you decide to do something like that, you know who to look for and what skill to look out for. And we're also going to cover what tools are out there to implement data analytics projects. Second part, we'll be dealing with the cloud, so that you get an overview of what the cloud is, what it can do, why it exists. And then we'll have a wrap-up session in the end. I'll try to finish between 5 and 10 minutes before the allotted time, so that there's ample room for questions. So concretely, the learning objectives of today are for you guys to learn what data analytics is, what job roles and tools there are, and what the cloud is and what you can do with it. So with that said, I would say let's start directly with the first part, data analytics. Without big data analytics, companies are blind and deaf, wandering out onto the web like deer on a freeway, is one quote. And another quote is, the goal is to turn data into information and information into insight. So you might remember from last week where I showed a slide of what data is and what its purpose is. So recall that there's something called the real world, right? Which is the sum of all facts, so everything that's the case. And basically what data is trying to do is it's trying to draw an image of this real world. It's trying to draw a representation of some aspect of it. For example, customer data is trying to draw, or is trying to depict the real world of my customers in forms of data. And then data analytics, if you want to take it one step further, is simply, once you have this image drawn by data, analyze it so that you can gain some insights and potentially draw some conclusions. So really, that's the essence of data analytics, is nothing else than, analyzing this image. An example, or how this would look for one example, is, let's say we have a website and we have visitors that visit this website. So this is our real world. If you, for instance, simply install Google Analytics, what it would do for you is it would collect data about your visitors. And once you have this data, you can analyze it, right? And you can try to answer certain questions you might have. For example, you might want to answer the question, how many visitors did I have in the last 28 days? Or you might answer the question, how do they come to my website? Is it through referral or organic search or Facebook or WhatsApp? You might also answer questions like, why is there a peak? You'll see in this graph, there's a peak in visitors. Where does it come from? Where are my website visitors based? What country are they based in? How many visitors will I have? So this is a prediction. Or you might also try to take this data to answer the question, should I put Google Ads to have more traffic and more website visitors in the future? And so when we talk about data analytics, we often talk about the so-called DIKW pyramid, which stands for data, information, knowledge, and wisdom. And so these things are often used interchangeably, but they're often thought of in terms of this pyramid because they have a slight significance in their meaning. And in general, we say that data is somehow the base for everything, and it's just raw. I don't want to use the term information, but it's just raw data. And when we turn data, when we do something with data and derive insights from it, then we say that we turn it into information. And so information is usually having a context, and it's informative to someone who consumes it. For example, if I now just give you some cryptic sensor data, you would probably not be able to make sense out of it. And so it's not informative to you. And if you have information which is informative to you, you can turn it into knowledge. And if you have knowledge and you acquire a lot of knowledge, you can distill the wisdom out of it. So we typically distinguish between the meaning of these concepts, and also the value. Obviously, everyone wants to be very wise and everyone wants to be very knowledgeable. But as you can see, the main thing to have that is data. And so this is just, again, to stress the importance of data. And if you want to engage in doing data analytics in your company, you have to invest in this asset, which might at some point come with costs. Good. So data analytics, the definition of simply gaining insights from data is very broad, right? And you might have already thought, hang on, if that's the definition of data analytics and if it encompasses so much, what types of analytics are there? And if you had that thought, then you're exactly right, because typically we distinguish between 4 different types of data analytics. And these 4 different types differ in terms of 2 things. They differ in terms of what time horizon they're looking at. And they also differ, secondly, in terms of how complex they are to implement. And the 4 types of analytics that are usually distinguished are descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So let's go through each one of those with an example. So descriptive analytics is typically looking at the past, and it's pretty easy to implement. And the main goal of descriptive analytics, or the main question it tries to answer, is what has happened? It's simply trying to give you an image of what has happened in the past. And so on top, I have an example of our book. And in this book, we have an example of an e-commerce store, which is selling toy cars. And so one descriptive analytics use case example could be, in this case, to answer the question, how many Ferraris did we sell last month? So you might imagine a simple visualization of data, which shows we have sold 10 on Friday and 8 on Saturday and 7 on Sunday. Now, if you want to take it a step further, the next step, or the next type of analytics, is what is called diagnostic analytics. And the answer, or the type of question that diagnostic analytics is trying to answer, is basically, why did something happen, or how did something happen? So its time focus is also still in the past, but typically is also, it's trying to inform the now, and so we're also looking at the present. And one example of this would be, okay, so we know how much Ferraris we sold last month. One question I might ask is, what influenced my sales, and why did we sell so few Ferraris last month? It could also be questions like, let's assume that you have implemented a marketing campaign and you want to know if this marketing campaign had an effect. So you could also, with this diagnostic analytics, answer the question, was my marketing campaign effective? You might also answer the question, how much money did I have to spend for Facebook ads, or for Instagram ads, or for Google ads in order to create one more sale on my website? So these are all topics that fall within this type of diagnostic analytics. If you want to take it a step further, then we're talking about predictive analytics. And predictive analytics is looking at the future, right? So typical questions you would like to answer with predictive analytics is, okay, so I have the data of how many Ferraris I sold last month. I also analyzed how much my marketing campaign had an effect on my sales. So what I'm interested in now is, by looking at the data, can I have a prediction of how many Ferraris I will sell next month? Yeah, there's many other examples and we'll cover those, so I'll leave it here. So we're typically trying to answer questions like, what will happen? When will something happen? What is the likelihood that something is going to happen, etc. And if you want to take it a step even further, we have prescriptive analytics, and it's basically trying to answer the question, how should we react to predictions? So let's assume we have some sort of prediction already. So we have a prediction that tomorrow we're going to sell 55 Ferraris. how should we react to these predictions, right? How many Ferraris do I have to order so that we avoid out of stock situations, but that we also avoid overstock situations? So prescriptive analytics is trying to prescribe you with the optimal way to react to a certain prediction you might have. So these are the 4 types of analytics. And again, they differ not only in the terms of time horizon they look at, but also in terms of their complexity. And this is also seen by the methods or by the disciplines that typically implement these analytics use cases. Or to put it differently, you would approach and use different methods for descriptive analytics than you would for diagnostic analytics, etc. They're all somehow interrelated, but to be very simplifying, usually descriptive analytics is what you do with data visualizations and sometimes also called descriptive statistics. So you can really think of dashboards. Think of your Google Analytics dashboard, which is visualizing how many website visitors you had, or how many sales you had, or how many requests you had. Whereas when we talk about diagnostic analytics use cases, this is really where statistics comes in. So this is where you would want someone who studied statistics, who is good with algebra, the math, and who knows statistical concepts. So that's an own thing in itself, which is not that easy and trivial. And predictive analytics and prescriptive analytics, this is really where the tools of machine learning and AI come into play. And we're going to look at how this works next week. And today I want to show you a few examples of descriptive and diagnostic analytics. Good. Let me stop here for now. So what I have in the next few slides is simply a few examples of data analytics use cases for each type, and I've tried to also have it for each industry. Edison gave me a bit of an input of what kind of companies are out there and out here in the webinar today. So I checked out a few and I hope that they're relevant. But yeah, let's just see. So let's start with a simple descriptive analytics use case for the IT sector. And this is just a screenshot from Google Analytics taken. One use case might be to answer the question, where are my users? So where are my website visitors? And this is a screenshot from my Google Analytics account. And you can see that most of people who visit my website are based in Germany. Then I guess after the webinar last week, we had a few people from Kenya, Nigeria, Ukraine, I don't know where they come from, and Bangladesh. Okay, so very simple. Descriptive analytics use case for agribusiness, and I have 2 of them. And these are based off the My John Deere app. A bit of background on that, because I love the story of My John Deere. John Deere, for those of you who don't know, is a company which manufactures agricultural equipment. So for instance, tractors or irrigation systems, or I don't know what. And they basically had the same business model since their inception. They were founded in the 19th century, I think, which was produce tractors and equipment and sell it. Now in 2014, and this is why I love this story, they decided to augment their traditional business model with a data-driven one. And so what they did is they equipped all of their machines with sensors, GPS sensors, weather sensors, temperature sensors, pressure sensors, and these sorts of things. And these sensors collect data on a constant basis of the farmers. And this data is being sent to the headquarters of John Deere. And basically what they have is a huge data asset of how their customers use their product. And what they did is they started monetizing this data asset. So they developed an app which is called My John Deere. And through this app, you can buy or use data-driven services, such as, for instance, to see what the status of different sections of your land system are. So it will tell you, hey, this field XYZ, you still have to put some fertilizer, or this one is ready for seeding, or this one you should harvest right now because tomorrow there's going to be a thunderstorm and it's going to destroy your crops. And so this is one service. And the descriptive analytics use case in this case is simply visualizing what is the status of different land sections. There's many other use cases that you can check out on the app, but another one that I've picked out here now is the question or the use case: how much yield have I produced last month or last week or last year? So simply displaying or visualizing how much have you harvested in the past, and maybe there's already some patterns in there, and maybe you see that I don't know, 2019 there was a peak or drop at some point because of a disaster. Good. Descriptive analytics use case for textile and apparel. This could be, for instance, a KPI dashboard which visualizes your sales data. And so there's actually also a few use cases or many questions that are answered through this, such as how much sales do I create per product category per day, let's say. And then you might see that, hey, I'm selling a lot of shirts and accessories, but I'm not selling so many t-shirts, right? And once you have this data, you can ask your question, okay, why? Is it that my target group is mostly interested in that? Is it because I display accessories on the landing page and t-shirts not? Is it because, I don't know, could be anything. You could also answer a second question, like how have my sales changed compared to last month, to see if there's a seasonal pattern. Maybe you find out that in November because you have Black Friday, or in December because you have Christmas, or in May because you have the end of Ramadan, you sell more. And this can inform how you deal with this, right? So you might offer special cases, or you might, based off of this data, adjust your marketing campaign or do other comparable things, right? So simply a dashboard of your sales data. Descriptive analytics for tourism, also a very simple example. You could simply ask, because I think I checked out some of the companies, and I think some of you offer tours. I don't know, a safari tour or waterfall tour or whatever. You could ask, okay, where do my tour requests come from? And maybe you find out that a lot of your requests come from China, or they come from the Netherlands, or they come from France. And if you find that out, you might say, okay, actually, because maybe the French people don't speak English so well, I should offer my website also in French. Yeah, so these were descriptive analytics examples. Let's move on to the next stage. And you'll see that it gets a bit more complicated, which is diagnostic analytics. Right, so this is a diagnostic analytics use case for agribusiness. I think some of you was a tea vendor, so you're producing tea and selling it. And one question you could ask is, if I add a discount on my website for a product, does it increase my sales? And the spoiler alert is yes, because in this case, as you see here, if you strike through a price and then offer an arguably cheaper price, this is a thing called anchoring. So it's a behavioral pattern of humans by which they perceive a certain price as cheaper if you give them an anchor which is much higher. So I'm sure you've seen this on many websites, and most of the stores and people that sell something on the internet make use of this principle, which is they give a high price, strike it through, and then give the normal price as discounted price. And so one question you might ask is, if I do that, do I sell more, or do I have a higher conversion rate? So let's say you do this for certain products on your website and you don't do it for others. Then you can check, okay, for each product, how many product views did I have, and how often was the product then sold? And ideally, what you're probably going to find is that if you offer this discount, which doesn't even have to be discount, right? It's just a psychological trick. You should see that your conversion is higher, and that on average you sell more products per product view. Olufu says she's unable to hear. I hope the rest can still hear me. Edison, can you give me a quick confirmation?
Yes,
Okay.
I can hear perfectly.
Okay, perfect. Good. Then moving on. Sorry, Olu, this is from your end. Diagnostic analytics in textile and apparel. Let's say you're selling t-shirts or other textiles directly to an end customer. I guess we also have B2B people here, but let's assume you're directly targeting end customers. One diagnostic analytics use case would be to analyze what affects your product ratings, right? So if you sell through an e-commerce store, your online store, you might be interested in figuring out what affects my rankings so that I can improve my rankings. Some variables you might want to consider are the price. Maybe if you offer a discount, like I just showed, maybe the delivery time, maybe the gender of the person buying it. And there's tons of other factors that I'm sure you know because you're the domain experts, what will affect someone's ranking. Now with the statistical analysis, you can actually do that mathematically and then determine, okay, the most important factor is discount. And if I offer a discount, on average, my product ratings will be 1 star higher than without discount. Or if you shorten your delivery time from 4 weeks to 1 week, the average review will also increase from 3 to 4, something like that. So these are questions that you would answer with diagnostic analytics. And as I said, you need statistical knowledge. So you need someone who studies statistics or some sort of it to implement something like that. Diagnostic analytics in tourism could be, for instance, you have, this is an example of A and B testing. And the principle behind it is, let's stay with the case from before that you realize, hey, I have a lot of people visiting my website from France and from Spain and from China and from Japan. What happens if I offer my website not only in English, but also in several other languages? Does this increase my click-through rate? So are more people clicking on a certain button that I want them to click on? Or you might also analyze sales, or you might analyze how much time a user is spending on your website. And what you can do is you can compare the setup when you have your website only in English with a setup where you offer your website in several languages. And this is one example of A and B testing, where the idea is that you test out different setups to see which setup works best in terms of a certain indicator. So here I took the daily clicks on a certain tool you might offer. And let's say you do that for 50 days with an only an English website, but then you switch the system and offer several languages and collect data on this for also 50 days. And then you can compare and answer the question, okay, if I offer my website in several languages, will this increase my daily clicks on a certain tour? If you find something like here, it's not a straightforward answer. So this is showing box plots, which is basically showing the distribution. And you see here, they're very similar. So it's difficult to say that this had an effect. But to really say this with confidence and analyze it, again, you would need statistical knowledge. Diagnostic analytics use case in the IT sector, let's say, I don't know, you're a web developer. One thing you might want to look at is, has my marketing campaign resulted in more website visits, right? It might be that you're doing Google ads or Facebook ads for yourself or for one of your clients who's selling a certain product. One thing you might want to look at is, if I do this marketing campaign, does it actually lead to more website visits, or is it does it not have an effect at all? And so again, what you would look at here is, this is simply a line chart which displays how many daily website visits you have. And let's say that sometime in September you had a marketing campaign. Ideally, what you would want to see is that on average your daily visits increase. But if you look at this, this is not straightforward to say yes or no. And again, we need statistical methods to do that. Good. So these were 4 examples of diagnostic analytics use cases. I hope they were relevant to, at least one of them was relevant to everyone present here. I'll show you just 2 or 3 predictive and prescriptive analytics use cases to give you basically a teaser, but we'll look at more of them next week. So one really cool app that is out there is called Tumaini. And this is basically their business model, or this app is an example of predictive analytics use case in the agribusiness sector. So what this app does is you can simply take a picture of your banana plant or of a banana if you are a banana farmer. And what this app will do is it will tell you your likelihood or the danger of your banana plant having a certain pest or a certain disease. So essentially what you're doing is you're predicting based off an image, a diagnosis for a plant or for a banana. So this is why this is called a predictive analytics use case. To create such a system is very complicated and it's based on machine learning. Again, just consume this like this for now. We'll talk about it more next week. Another predictive and prescriptive analytics use case example from my book, again, from our book, is Think Back of the e-commerce store, which is selling toy cars. One predictive analytics use case would be to predict the likelihood that a website visitor will click on a certain product link. So let's say I have 10 products on my website. I could write an algorithm which, based on the profile of a visitor, the age, the gender, the location, gives me a prediction of the likelihood that someone will click. And if you take this a step further, we can also ask then, okay, I predict that this visitor is most likely clicking on a Mercedes toy car. But what can I do to make this visitor then buy this car? And one use case would be to calculate the optimal discount to offer to a visitor to make them click on a product link. This is called dynamic pricing because we don't apply one price to everyone, but we adjust the price based on somebody's profile. This is happening, for example, when you buy flight tickets with search engines. Typically, if you have looked quite a bit already, or if you pick a certain day at which you look at prices, there'll be different prices for you. So airlines adjust their prices all the time so that they are low enough to beat the competition, but high enough to not make losses. So they're heavily using predictive and prescriptive analytics. Good. Again, we'll look at more next week, so do feel free to join them. Good. So we've had a look at a few analytics use cases. We know what it is. The question is what tools are out there to implement it. So for that, we first need to distinguish between different types of data analytics tools. There's, on the one hand, software tools. And there's, on the other hand, also something called programming languages. And programming languages are really, you can think of them as dictionaries that you can download for your computer. And with these dictionaries, you can talk to your computer in a certain language. Some programming languages are Java or Python or C+ or C#. I'm sure you've heard of them. So programming languages are usually a very low-level tool because you can directly communicate with a computer and it gives you a lot of flexibility, but it's very complicated to learn. When you use programming languages, there's other concepts such as libraries, compilers, and your interface, but I'll leave them out for now. Just take away from now is that programming languages allow you to communicate with a computer at a very low level, and it allows you to do a lot of things. Now we also have dedicated software tools such as Excel or other software tools, which basically they are written in a certain programming languages and they have libraries and all of these sorts of things. And so they're much higher level, which means they're typically easier to learn, but they're also less flexible. So just keep this distinction in mind. And I've created a small list, which is by no means exhaustive, of a few certain tools that are often used to implement descriptive, diagnostic, predictive, or prescriptive analytics use cases. So Excel, for instance, can be used to do descriptive analytics and diagnostic analytics, right? Because you can run some statistical analysis, but mostly what you can do is simply visualize data that you have. This is static with Excel. And if you want to create interactive dashboards, you have to resort to other tools such as ClickSense or Power BI or Tableau. So interactive in this case means you have data visualizations, but in your visualizations, you can click, for instance, on your sales last month and then see your sales per category. There's also another tool called Infogram, or you can simply use Google Analytics, which is a visualization tool for your website. They all offer similar capabilities, the interactive ones. So yeah, it's a matter of, I guess, pricing and yeah, preferences. I don't want to give any recommendations here. For diagnostic analytics, you have other tools, so SAS or MATLAB or Stata, that allow you to do statistical analysis. But usually these tools are limited when you don't want to do machine learning and AI. So there's different tools like RapidMiner, like BigML, or like NIME, which you can use to do machine learning and create implement predictive or prescriptive analytics use cases. Good, so these are all softwares, but then as I mentioned, there's also programming languages. And because with programming languages, you can tell your computer directly what to do and how to do it, like mathematically. Basically, you can use programming languages for anything of those things. And so the most famous programming language in that is Python, which is used in software development, but also for data analysis and to implement such use cases like here. Its main competitor is R. If you decide to pick up or have someone in your team pick up one of those, I would definitely recommend Python because I think R will disappear, but that just as a side note. Good. Then you see in the right side that there's also a thing that I mentioned called cloud, and we're going to look into that, but we'll see that there's many cloud services that you can use to also implement your use case. Okay, I'm speeding up a little bit for time reasons. Okay, so let's say you have identified a use case, and we're going to learn how to identify use cases in webinar 4 and 5. Let's just say you have one, think of one of the examples, then how would you implement it? Basically, there's a life cycle in how you implement use cases, data analytics use cases, or projects, or maybe it's a product also. And basically you undergo through 4 phases. Business understanding, which is basically brainstorming what your idea behind this use case is. What are you interested in? Are you interested in figuring out what happened in the past? Are you interested in doing a statistical analysis to see if your marketing campaign was relevant, etc.? So this is really, tell me what you want to do. Then in the second phase, someone like me can tell you, okay, if you want to do this, we need this data. So we must collect, transform, and clean the relevant data from these and these sources. So this is what happens in the second phase, which is data preparation. Then in the third phase, what you would do is you would do the analysis. So you would create the dashboard, or you do a statistical analysis, or you do your machine learning model. This depends on what kind of use case you have. And then in the last phase, you would try to make what you've created available to the users. So maybe you would give them the dashboard and host it somewhere, or maybe you would give them results of your statistical analysis. Regardless of what type of data analytics use case you have, you always undergo this sort of timeline. And because this is not very trivial, typically on such a project, you have different job roles. And with job roles, I mean roles and not people, because you might also do everything by yourself, or one person can go through all of these phases if they have the relevant job role skills. So typically when we talk about business understanding, this is where you'll have your business analyst, the person who is doing the data preparation, so getting data from different sources, from databases or from websites, is called a data engineer. If you have a visualization use case, someone who's creating a dashboard is called a data artist or a visualization expert. If you have more advanced use cases, this would be your machine learning engineer. Or if you have a statistical use case, simply a statistician. And the deployment is typically where a software engineer comes into play. Last time we talked about data, and obviously all of these things that we talked about today assume that you have data assets available already in a database or in Excel, on your website or somewhere else. If you don't have that, the person who would help you set up the right tools for you to collect data is called a data architect, or also a software engineer, depending on how you set it up. Good. Then a data scientist is somehow a unicorn who is expected to be able to do everything, right? So we are now in the industry is slowly stopping to use data scientist as a job role because it's just too broad. It's a bit like saying someone is a doctor, whereas actually you have neurologists, you have dermatologists, you have dentists. And so what we're seeing in the industry now is that data scientist as a job role is disappearing, and it's being differentiated into data engineer, machine learning engineer, visualization expert, etc. But I still call myself data scientist because I'm not a specialist in one of these things. So I don't have a lot of depth knowledge, but I have quite a broad knowledge of most of these things. Good. So this was the topic data analytics. So from last week, we have data, we know what it is. This was basically what can you do with it, with a few examples. And we're going to have more examples next week. One thing I want everyone to know is also the concept of the cloud. And I've already mentioned that there are certain cloud services that you can use to implement projects. So we're going to talk about what the cloud is and how you can use it. And cloud computing really is a great euphemism for centralization of computer services under one server. Good. I'll skip these slides. I'll come directly to this. I'm sure most of you have heard of the term cloud. And some of you might already have a good understanding of what it is. Some of you might be a bit confused. To understand the cloud, you must understand a concept which is called client-server architectures. And what I want you to do is think of any sort of app you have on your phone or any other application you use on your computer. Then usually most of these apps follow a certain client-server architecture. And the way it works is that to, let's say, have WhatsApp running on your phone, you divide the workload between what your phone does and what some server of WhatsApp company, or in this case, Facebook company, is doing. So you have the WhatsApp app running on your phone and it's performing certain tasks. But in this case, the data is not residing on your phone. It's actually residing on some server. I don't know how exactly they make this trade-off. But for most of the apps, some workload will be done by you as a client. So your smartphone or your computer, or maybe you have a server. And some will be done by some remote server. And the way it's orchestrated is basically through the internet, right? And understanding this concept is crucial to understand the cloud, because what the cloud is basically nothing else than computing resources. So this could be data storage, it could be computing power, it could be execution of software, it could be analysis of data. Computing resources like these, which can be rented on demand, right? So basically the cloud allows you to strike this trade-off between what your smartphone does and what some server does in any shape or form. But you can rent the computing sources of some server on demand if you want to. And to be very concrete and very specific, there are a few cloud providers out there, and together they make up what is called the cloud, quote unquote. And really it's nothing else than huge, really enormous data centers that are out there. this is basically the cloud. It's just a network of very strong and powerful computers where you can store data or where you can rent data resources. A colleague of mine, liked to say that the cloud is nothing else than using someone else's computer. And that's a good way, I think, to think about it. Now, there are different types of cloud services that we distinguish. And they differ in terms of they differ in terms of the client server architecture. What do you have the cloud do for you? And what do you have your app do for you? And so in this regard, we typically distinguish between cloud models or cloud types: on-premise, infrastructure as a service, so IaaS, platform as a service, PaaS, and software as a service. An example of one cloud architecture that is very simple is Gmail, right? I think most of you use Gmail. And if you, like me, log into your Gmail account through a web browser, then this is an example of SaaS. So it's a software as a service that is offered by Google. Why? Because everything that you need to run this application Gmail is stored on a server. You have your emails there. It's hosted somewhere, like the application is hosted somewhere on a Google server, including all of the computer, the service, the storage, the networking, the operating system, OS. Everything is done by Google. And you simply have to log in through your web browser. Okay, so that's an example of software as a service. The other extreme would be infrastructure as a service, where you only rent hardware. So let's say you want to develop an app, or you want to create your own app and host it somewhere, then you would only rent a computer where you host all of this. This is called infrastructure as a service. Basically, a website is one form of IaaS, I guess, because you simply rent one computer where you store your website. And the middle thing, so if you take care of some things which are not only hardware but also somehow software, so the operating system, sorry, let me restart again. In the middle way between IaaS and SaaS would be PaaS, platform as a service. And the idea is that you take care of the data and the applications, but you're renting the hardware, including some basic other components that you need to run a software, such as the operating system, such as some middleware, such as some runtime. Good, so these are cloud models. If you don't want to use the cloud, then your alternative would be to do everything on premise. So it means you buy a hardware server, you install the operating system, you take care of networking, you take care of the storage, you assign it an IP address, you create your app, you host this app or your website or web app on there, and you do everything by yourself. Now the cloud has enabled us that we don't have to do this anymore. And today there's also more services that go beyond software as a service. So machine learning as a service, AI as a service, video ads as a service, etc. I've mentioned that there's many cloud providers, but really the main three ones are Amazon Web Services, so AWS, Microsoft Azure, and Google Cloud. And these three companies have the main market share of all cloud services. Right. I'll leave it for that. Maybe just one tip. Yeah, if you use Google Cloud, they also give you $300 of credit, just like this. So yeah, basically, what you can do is you can buy services, so you can rent computers, or you can rent machine learning services, or you can rent hosting services for your app with any of these cloud service providers. And the big advantage is that you're renting things rather than buying things. So let's say you want to create an app or store some data. Let's simply say you want to store some data. What you would need to do is, if you do everything on premise, you would need to physically buy a hard disk and then store all of the data by yourself. This has high investment costs, and it's not so flexible, because what happens if you need to store more data, or if you store much less data than you're actually capable of with your hard drive? Whereas with the cloud, you can adjust the computing resources that you need based on what you need for a certain month or minute or even second, right? So you can perfectly adjust what you need by simply renting it. And if you don't need it anymore, you can simply say, no, I don't need it anymore, and I want to stop renting it. So you only pay as you go. So that's a big advantage of cloud services. So one example I have here is of AWS. They offer a service which is called S3, so simple data storage. And what you can do is you can simply create what is called buckets. And in these buckets, you can put files and share them with other people. Yeah. Or another example of one cloud service, this is one from Google Cloud, is they have machine learning as a service. And so what they have is a service where you can rent object classification. So basically you can implement a machine learning algorithm which classifies, in this case, houses for you. And what you would do is you would only pay per classification. So rather than training your own model, which takes a lot of time, you can simply rent their very intelligent model and use it for your services as you need it. Other examples of cloud services are, for instance, chatbots. So you can simply buy chatbots from Google or someone, and you would only pay per every time a user uses your chatbot, for example. Good. So this was a small introduction into the cloud. Again, the cloud is nothing else than renting computer resources. And this could be hardware, but this can also be software. That's the very simplified version of it. You only pay for what you use because you're renting and you're not buying things. So this has the big advantage that you don't have any upfront costs with investments, right? And so I think the cloud can be very powerful for extremely small companies like you and me. Good. Let me finish off by giving 3 practical advices, which are also somehow the recap of today, which is advice 1. Use your data. So last time we talked about data. Let's assume that you start collecting data now. Once you have that, then you can really start the fun part and putting it to use with analytics. So as soon as you have data already, start playing around with it. Start visualizing it in Excel, or maybe download a free version of Tableau or Click, or just look into your Google Analytics and start analyzing. Advice number 2, try to reverse engineer and figure out what you want before you choose how to go about it. So think about the process I showed before, business understanding. Tell me what you need. Is it a dashboard? Is it some sort of visualization? Is it a statistical analysis? And once you're very clear on what you need, then you can answer the questions like, what data would you need to implement such a use case? What format would it have? What skills are necessary to implement it? And what tools should you use? Okay, so always try to be goal-driven and think of the goal you want to implement in the future. And then this will give you guidance on what data you should collect, what tools, what skills you need, etc. And advice number 3, we went through this quite quick now because I had time management issues, but don't forget the cloud, okay? The cloud is extremely powerful. Please do go on one of the cloud providers' websites and check out what they offer, because it's extremely powerful. They offer a lot of services. It's very flexible, it's cheap, and it's very easy to use. So this ranges from everything from storage to computing power, to hosting your websites, to chatbots, to object classification, to sentiment detection. There's really a lot of things that you can do. And I'll touch upon more of these services as we go along next week when we talk about machine learning and AI. Good. So small recap of what we looked at today is we looked at data analytics and saw a lot of examples. Data analytics is simply gaining insights from data assets you have, and there's different types of analytics. We looked at the cloud, which is nothing else than renting someone else's computer. And this can, for instance, be done to implement a data analytics use case. But it could also, for instance, just be used to store your data and make it available to other users. And we've had a look at a few implications of what this means for you. Okay, let me open the floor to questions now and hand it to you, Edison.
Hi, thank you, Michael. Again, very easily understood, very comprehensive. Before I take on questions, I have a small one.
Yeah.
I know that you talked a little bit about IaaS and SaaS. Am I right?
Yes.
I think.
Yes.
Yeah. No. Sorry. Yeah. Exactly. And you gave an example of IaaS as maybe Gmail, and IaaS as maybe just renting the computer or something like this. But you didn't give an example for platform as a service. So would you have an example of that so we can kind of understand,
Yes.
maybe something that we're used to?
Okay. I skipped it intentionally because it's a bit difficult to understand. And I like to think of the two extremes, software as a service, because this is what everyone is using with all of your apps, basically. This is software as a service. And IaaS is simply the hardware. But let's say that you want to develop an app by yourself. Then you would use platform as a service. So the cloud provider will provide you with a platform and with all the resources that you need to build your web app, for instance. So they will give you the hardware, they will give you computers, they will give you a few software with it, like operating systems, and they will install, let's say, a few programming languages so that you don't have to configure all of this and simply start creating your own app directly.
So would it be correct to say maybe something like, what is that blog? Maybe like Wix.com, right? Is that a platform as a service?
In a simplified version, I guess you can say it, though I think from an IT perspective, you think of different things. But yeah, something like that, I guess.
So,
Yeah.
okay. We do have a lot of questions.
Yes.
I would like to begin from a point of maybe Joanne, sorry.
Yeah.
You talked about cloud types is not just, I don't know what a chaff script is, but she has not understood that much. Joanne, would you like to elaborate on that? Maybe Joanne, I will unmute you and see if you could pose your question. Is there something that you don't understand? Hold on, let's see if I can unmute you. Joanne, could you try unmuting yourself? Yeah, okay, perfect.
Thank you. I just want to understand if there's a way the types can be made easier, because it's quite difficult for people who are not much IT savvy to understand the cloud types. It's it's sort of a difficult section for someone who doesn't know much to understand.
Right.
Yeah.
Sure. Sure. Yeah, that's my bad. I spent too much time on the data analytics part and didn't have enough time on the cloud. But let's say, Joanne, are you from which sector are you?
We do jewelry. Let's say fashion accessory.
Fashion accessory. Okay. Yes. Right. Cool. Let's say that you want. And be strong. Okay. So the cloud. Which one? Can everyone mute himself again?
Yes, I will mute everyone. Okay. Okay. Hold on.
Okay. Perfect. Good. Yeah. So cloud services, really think of it as using someone else's computer whenever you have limitations to your own computer. So maybe in your case, it's not the case that you have so much data that you cannot store it on your computer anymore. And maybe in your case, you're also the only person working in your company, and you have everything stored on your laptop that you need to operate your business. But let's say you want to create a dashboard, and you want to share this dashboard with people outside of your company, maybe with your clients or maybe with teams you have somewhere else. Then you would need to have computing resources that go beyond your own computer, right? And this is really where cloud services come into play. Because what these cloud service providers give you is they allow you to rent their computers for whatever you want to do on a minute on demand basis. So if you say, hey, I have so much data that I cannot store it on my computer now, you can simply rent space to store it somewhere in the cloud. Let's say you have created a dashboard that you would like to share with other users beyond yourself. Then you can buy a service that lets you share this so that someone like me or Edison in Geneva can access it simply through a web browser. So this is how the cloud works in general. And because this is very complex, you distinguish between different cloud types. And you have many cloud services, each of which falls within one of these cloud types. And these are the infrastructure, the platform, or software as a service. And so these types differ in terms of how much workload you give to the cloud provider and how much workload you take care of by yourself. I hope that's a simpler explanation of things.
Thank you, Michael. I will move on to a relevant question, very relevant one. How do we make sure that the cloud we use is secure? And are there any additional precautions we could take?
Sure. The cloud is secure, I would say. So in general, right, you have these one models. Well, one model is everything on premise, so you do everything with computers by yourself. And the other model is you use some sort of cloud services. Now, if you use cloud services, necessarily you're going to have some data which you send from your system to the cloud, which might be, for instance, in Frankfurt or in New York. And people always think, and it's true, that there's a heightened danger once you send data around. It's more susceptible to be attacked. However, what you have to keep in mind is that literally the most intelligent experts on data security are working for these companies. And so the companies themselves, AWS, Google Cloud, and Microsoft Azure, invest a lot of money and have a lot of features to keep your data secure. So in general, I would say, yes, the data is secure because you have the most intelligent people taking care of your security. And it's even more secure than if you simply have it on your laptop, right? Because I guess someone can more easily hack your laptop than they can hack the Google Cloud. Now that said, yes, you do send your data around the globe. And yes, there is a certain level of danger there. But again, the cloud service providers offer a lot of functionality. You can encrypt data, you can make it password protected, and you can only grant certain people access to it, etc. So there's all things taken care of, and security is not really an issue that I think is critical.
Thank you, Michael. I would also ask everyone to fill out the poll. There's a little window that has popped up on your screen, and it'd be great if you could fill it up. There's still half of you who haven't, and really appreciate your inputs. Next question is very relevant again, because for SMEs, right, they have very limited budget as small businesses. So, how are they going to get started? How are they going to hire a good data scientist to get things rolling when it comes to data analytics?
Mm-hmm. That's a good question. So data scientists are in very high demand right now. And so typically their rate is pretty high. So concretely, I hope that these webinars give you a bit of knowledge so you can get on your own feet and start implementing things by yourself by the end. And that's option one. Option two is if you have especially questions like, okay, I have this data and I want to create a dashboard, what tool should I use? If you need some pointers, then you can ask me. So reach out to me on LinkedIn and I will get back. I might take a few days, but I will get back. And the third one is, look for the relevant job profile and aim for interns. So I know that, or people with little experience, with little practical experience, but who have the knowledge to do it. So I very often get contacted by people from India, or I don't know, who would be happy to do projects and implement things, because they also have an interest to create a portfolio for them and to gain work experience. And I guess they don't have such high fees, and maybe you can also strike a deal with them where you say, do this analysis for me, create this dashboard, and in return you get a testimony from me, or some sort of other non-monetary benefit. That's the 3 tips I would have.
I was wondering, thinking of saying that, the goal of this webinar series is to not just help everyone understand the basic concepts of digital transformation and, AI, machine learning, cloud, for example, but also towards the end, everyone will get a somewhat of an idea of what a data strategy is. And I think, correct me if I'm wrong, Michael, that at the crux of it, the foundation of it is a good data collection and good data architecture.
Exactly.
So it begins from, how you save and, your data, how you label them. And I think at the end of the day, in the 5-part series, this is something you can start to apply to your businesses. Maybe just improve your data collection, how you store them. And there are a lot of softwares out there. For example, I think IBM has this where you can actually just feed information into there. There are inbuilt models that you can use to visualize data. So this is, yes, I think you can have data scientists who can help you, but some of these stuff, you can start taking courses that are available. Some of them are free to start implementing yourselves, right? Is that correct to say?
Yeah, exactly. So by the end of this webinar series, ideally you have a few use case ideas for yourself. And in the last webinar, we'll also talk about, okay, if you have one now, how do I practically implement it?
I was telling Michael that ever since he delivered some mentoring sessions with under phase 1 of the project, I started to take some courses on AI and machine learning. And then after a few courses, I learned how to build my own chatbot without knowing coding. So it's not something that is rocket science. Everyone can do it. It just takes some time to learn. A few weeks, I would say. For me, it took 3 weeks to learn how to create a simple chatbot. And that leads me to another question. I'm going to skip a few questions, and someone talked about chatbot. So Abi Abraham, what is a chatbot used for? How is it relevant for small businesses that mainly target social media platforms? Is it more relevant for you if you're an app or website? What size of data is stored in a chatbot?
Okay, that's a good point. So chatbots is also one service that you can simply buy from cloud service providers. So basically it's an intelligence system which is able to communicate with a user and answer questions to that user. And to create such a system by yourself would be very, very complicated, right? But you can simply rent the service from a cloud service provider, and it can be used in many ways. And but let's say you include chatbot on your website. One use case might be to help your user answer certain questions. So instead of having an FAQ section, let's say, I don't know if you have a technical product, you could implement a chatbot which gives the right answer to the user rather than him or her having to look through FAQs. You can also, Pipedrive is offering a chatbot like that, which is very cool. You can also use a chatbot to maneuver requests. So let's say you're a tourism company. You could have a chatbot which is available 24/7 to everyone, which helps your visitor find the right tour for them, right? So you could ask through a chatbot, for instance, hi, welcome to the website. Why are you here? And then you can give the options, I'm here just to look around, I want to book. And if they click on I want to book, then you can say, okay, great. Are you interested in animals or nature or city? And then they click animals and they can say, cool, we have 5 tours to look at safaris. This is the link, check them out, right? So you can sort of guide your user through your website, which is a better user experience for him and her. And you can collect the data on what people are interested in, and then you can do other use cases. Yeah, and the size of data that is stored on chatbot depends on your website, but it's pretty small, right? It's per user, I don't know, a few kilobytes, so it's not a lot. So you don't need huge computing resources to store the data.
Thank you, Michael. Okay, Lara Cookie, are you saying that creating an app for my business is a good option to get data analytics from our customers?
Yes, by all means. So this is, for instance, what John Deere did. This is also what a company did that we work for, a Swiss company who creates kitchen equipment. And they just produced kitchen equipment previously, but what they did is they also installed sensors and then also developed an app. And so now previously they had literally no idea how their customers are using their services, how they like them, how they had no customer data at all, no user data. And with the app, they were able to now track the customers, see when they're using their kitchen equipment. So this was a mixer, how they're using it, what kind of recipes they cook. And this collected a lot of very valuable data for the company of their users. And if you can create a web app or an app that is used by users, that's an excellent way to collect data and gain some more insights.
But what about for, I'm asking this on behalf of everyone. I think, you know, it takes a lot of investments for a lot of the SMEs we work with to start that app by themselves, but maybe something that is more accessible, you know, like Google Analytics is something that is free and they could use for their digital marketing.
Right.
But I think the basis for that is that they need a website, and that I think maybe many SMEs should have.
Yeah, so I mean, if you have a website, the most basic thing is install Google Analytics, and it will take care of data collection for a lot of things. If you want to take it a step further, you can do something which is called quiz funneling, or include a chatbot, so you collect even more data about your website users. If you don't have a website, so this is very easy, right? Google Analytics, to install it on your website is like 2 clicks. So that's, I think, everyone with a website can do. If you don't have data, you know, and you're like very basic, let's say, I don't know, you're producing bananas, simply work with Excel sheets and start recording how many fertilizer you give, how many bananas you harvest. Just start tracking everything you do and start it in Excel. That's okay, you know, as long as you somehow collect the data, that's okay, and we can make use of it.
Yeah, I also want to add that, you know, on the most of the most common apps that we use, like Instagram for social media or Twitter, they've also inbuilt analytics. So sometimes to look at how it could shape your behavior in marketing would be a way to explore these apps and then see, you know, hey, this is interesting for me. Maybe I should tweet a certain way. I should post certain things in a certain way. And that, of course, is applicable across your entire business model. Okay, I'll move on to a few last 2 questions because I know Michael has a mentoring session coming up. Okay, I've asked about from Abudu. So can I start off with analyzing my website visitors and then push suggestive information to them based on the landing pages they went to?
Yes, absolutely. That's a great way to start. So, you know, Google Analytics, collect some data and then see how, look at the Sankey diagram. The Sankey diagram shows you, shows you the user behavior and the flow on your website. So it'll show you, 90% of all people on your website arrive on your landing page. And then out of these 90% from the landing page, 40% click on link A and 50% click on link B and 10% click on link C. And if your goal is that people from the landing page click on link C, then one thing you can try out is to have a pop-up, right? Or some sort of notification, which says, by the way, we have this amazing discount for product XYZ. Click on it right now because the discount is only available for 10 more minutes. And once you do that, then you can analyze, does this increase the click rate of button C, which is your goal? So yeah, Google Analytics, absolute basics. And once you have that, you can start playing around with it. Yeah,
Thank you.
diagram.
So we have an additional question from the same person, Ms. Abudu. How can I adopt analytics in real estate development? Wow, okay. To see who the target market is and target them more specifically. Well, that's a very specific question.
Sorry, can you repeat the question?
How can I adopt analytics in real estate development?
Okay.
To see who the target market is.
Right. So this is also something I guess you would do through a website. So let's say you are a real estate developer and you have a few products in your portfolio, a few flats. What you could try to track is for each flat, where is the user based? So Google Analytics does this for you. They collect from where a website user logs in. They typically also have data on their age, on their profession, etc. And you can again simply have Google Analytics do the job for you.
Great. And the last question, last one, I promise. Can we rent a website or create a rented website as well for companies that do not have existing websites? I think this is an easy question for you, Michael.
Yes, of course. So this is the area of web development. And by now there's many tools that make it very easy for you to build your website, and they take care of renting the web space for you. They take care of assigning the domain, they take care of everything else. And literally the only thing you're faced with is, in a drag and drop way, build your website. One example is Wix, this Edison has mentioned, which is very easy to use. There's a few other ones. And if you want to be a bit more customizable and take it one level further, you can go with something called WordPress. But then you would have to rent the web space yourself from a cloud service provider.
Okay, perfect. I think we've covered a lot of grounds today, and I think everyone would appreciate the sector-specific examples you gave.
Yeah.
And for the next session, I believe it would be on machine learning and AI.
Right.
And that's where you start seeing applications and more in-depth stuff. So I really must thank Michael again. It's a great presentation. And I'm very sure that all the attendees feel the same way. And I look forward to seeing all of you for the third session. And thank you, Michael, once again. Please follow him on LinkedIn, have a look at his book if you'd like to learn more. And also to review this session and the previous one if you want to really get a very strong understanding and be prepared for the third session.
Yeah.
So thank you everyone again. Thank you, Michael, and I'll see you for the mentoring session.
Yeah, thanks everyone for being here and hope to see you next week.
Thank you everyone. Have a great week. Ciao.
Bye-bye.